I am Aligar Lingappa, Assistant Professor in Physics at TSHMS Government Postgraduate College, Sirguppa. So today's my chapter is waves. So today I have discussed about the basic concept such as wave motion. Wave motion what is wave motion? Wave motion is the transfer of energy and momentum from one point of the medium to another point of the medium without any actual transfer of matter between 2 points. Wave motion is classified into mainly three types. Here, wave motion means the transfer of energy in the form of disturbance from one place to another place without actual movement of the particle of the matter or particle of the medium, so called wave motion. The wave motion, which can be classified into many types: the medium of propagation, the dimensions in which a wave propagates energy, then energy transfer. So the classification of wave motion are based on the medium of propagation. So that means the wave motion, which can be classified into many types based on the medium required for their propagation, then the dimensions, then the energy transfer. There are the different types of wave motion. So based on classification, that means based on the medium required for their propagation, based on that, the waves that can be classified into are two types, say mechanical waves and then non-mechanical waves. Then what are mechanical waves? Waves that require a medium for that propagation are called mechanical waves or elastic waves. The particles of the medium execute a periodic motion about a mean position when the wave propagates through the medium. So mechanical wave means the wave which required for its propagation is known as elastic wave. In the medium, the particles they execute periodic oscillatory motion about their mean positions when the wave propagates through it. So the examples for mechanical waves: waves on a string, waves on a spring, waves on a water surface, then sound waves. These are the examples for mechanical waves. So properties of medium for mechanical wave propagation. The medium must possess inertia so that its particles can store kinetic energy. The medium must possess elasticity. The minimum frictional force between the particles of the medium. So these are the properties of the medium so required for the propagation of mechanical waves. Non-mechanical waves, waves which do not require a material medium for their propagation are called non-mechanical waves. That means some of the waves in our nature, they do not require the material medium for their propagation. So they are called non-mechanical waves. So these types of waves can propagate through vacuum also. These are transverse in nature. Example, electromagnetic waves and then matter waves. Transverse wave motion, the particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave. The region of maximum upward displacement is called the crest. The region of maximum downward displacement is called a trough. So transverse wave motion means during the propagation of transverse wave in any medium, where the particles in that medium vibrates perpendicular to the direction of propagation of the wave. It consists of series of crests and troughs. The region of maximum upward displacement is called crest. The region of maximum downward displacement is called a trough. So the nature of propagation of transverse wave in a given medium. So example, string waves. That means waves along a stretched strings. In that string where the particles, they are vibrating up and down. So perpendicular to the direction of propagation of the disturbance or energy. Then electromagnetic waves, say light waves. During the propagation of light waves, where the particles, so they are vibrating perpendicular to the direction of propagation. Then ripples on water surface, where the water particles, they are vibrating perpendicular to the direction of propagation of disturbance or the direction of propagation of energy. So the definition of transverse wave motion, the examples for transverse waves. So now you see the waves along a stretched string. So one end is fixed to the rigid support, say a fixed end. Another end is a free end. If the free end is moved up and down, then it where the rope, that means the string which moves up and down, where the disturbance which propagates from free end to fixed end, where the particles in the rope or string vibrates perpendicular to the direction of propagation of the disturbance, which form series of crests and troughs. Whereas C, that indicates a crest, and T, that indicates a trough. So that means the nature of propagation of transverse wave. Longitudinal wave motion. The particles of the medium vibrate about their equilibrium position in a direction parallel to the direction of propagation of the wave is called longitudinal waves. Longitudinal waves require a medium with only elasticity of volume or bulk modulus for its propagation. In this type of wave motion, the waves travel through a medium in the form of compressions and rarefactions. As spring waves, then the sound waves, they are the good examples for longitudinal wave motion. That means during the propagation of longitudinal waves in any medium where the particles, they exhibit vibratory motion about their equilibrium position or a mean position in a direction parallel to the direction of propagation of the wave. So during the propagation of longitudinal waves, we are forming a series of compressions and rarefactions. The examples are spring waves, maybe sound waves. So now you see the diagram. The waves along a spring, where indicates a series of compressions and rarefactions. One end of the spring is fixed to the rigid support, another end is a free end. If a disturbance is given to the free end, then where the turns they can oscillate horizontally, that means in the direction of propagation of the disturbance. So longitudinal waves along a stretched spring, a good example for longitudinal waves. A compression means it is a region in the longitudinal waves where the particles are very close to each other, pressure is more, volume is less, temperature is more. Then the rarefaction means it is a region in the longitudinal waves where particles are far to each other, temperature is less, pressure is less, volume is more. That means where the compressions, rarefactions, they are formed during the propagation of longitudinal waves. Based on transfer of energy, the waves they can be classified into two types. Say standing waves and the progressive waves. Then what are standing waves? What are progressive waves? Standing waves means these are the waves in which no transfer of energy and momentum. They are called stationary waves. No transfer of both energy and momentum. Then progressive waves. These are the waves which transfers energy and momentum from one place to another place. So called progressive waves. Standing waves. They are the two types of waves based on the transfer of energy. So again the waves they can be classified into three types based on the number of dimensions of wave propagates energy. One-dimensional waves, two-dimensional waves, three-dimensional waves. Then what are one-dimensional waves? What are two-dimensional waves? What are three-dimensional waves? Here one-dimensional waves means the waves which produced in a stretched string, waves which traverse along a straight path, along a straight line, so called one-dimensional waves. Examples are waves along a stretched string or spring. Two-dimensional waves means the waves which propagates on a plane. Examples are ripples on the water surface. Three-dimensional waves, the waves which propagates in all the directions, that means in space. Examples are propagation of light and sound waves. So one-dimensional waves, two-dimensional waves, three-dimensional waves, they are the three different types of waves based on their dimensions. Thank you.